Hey guys, we're going to do another video here on quadratic formula. And the quadratic formula is this fun little thing where we're trying to solve for x when we have an x squared in our equation. And so we have this formula, negative b plus or minus square root b squared minus 4ac over 2a. Kind of a long formula, but we memorize it, we get it kind of stuck in our head. And it all is based on the a, b, c's, the three numbers in our quadratic expression. And so we want to be able to solve these quadratic problems, but I gotta say some of them are going to not be as obvious as others. So I want to look at an example a little different than my last video on this. It's at least a little bit more complicated. So here, let me show you one that's a little bit different. Let's say I had negative 3x plus 2x squared equals 5. And I told you the directions were to solve for x. So I'll write that up here. Solve for x is my directions. Normally when I see a problem that says solve for x, I kind of think of the line down the middle of the equal sign and I start flipping and moving things to get x isolated so that I have x equals in an answer. That's usually what I try and do. But in this case, there's an x and an x squared, so really I'm not going to be able to do that. I'm going to need another strategy. So I either can factor and try to turn this into like a double parenthesis problem, or I can use this quadratic formula. And because of the video and what we're doing, I definitely want to use the quadratic formula to kind of practice this. So there's a couple of things we need to do. Before I can use the formula, it needs to be in this format, ax squared plus bx plus c. So in this case, the x squared's here, the x is here, the 5's over here. It's kind of all out of order, and we need to fix it basically. The 2x squared typically would go first, then the minus 3x, and then the 5 should be with it, but it should be on the other side of the equal sign. It should be over here, a minus 5 equals 0. The setup on these is they should be equal to 0. If you're going to use the quadratic formula, this thing's got to be in the format ax squared plus bx plus c equals 0. So we need to move those equations around and put it into what we call standard form. And that's really important. You've got to pay very close attention so that you can identify what your a equals, your b equals, and your c equals. And now that I've fixed this up, now I see a is 2, and b is the minus 3, the negative 3, and c is the minus 5, negative 5. It's not a positive 5. I had to flip it over to the other side of the equal sign. It's a minus 5. But once I kind of track that down and figure that out, I'm ready to solve for my two roots, my two x-intercepts. And the way I'm going to do that is I'm going to solve first for the plus part of the equation and then for the minus. So x equals negative b plus the square root of b squared minus 4ac all over 2a. That equation is going to give me an answer. And then on this side, I'm going to do x equals negative b minus the square root of b squared minus 4ac over 2a. And I mean, really take a good look at this. These two equations are identical. The only thing different is this is plus and this is minus. But I'm going to get two answers for x. So knowing how to solve, I'm going to go x equals negative b, so negative blank, plus big square root b squared, so blank squared, minus 4ac, so 4 blank blank, all over 2 times blank. And then what I'm going to do is I'm going to fill the ABCs in with what I know. So if it's supposed to be a negative b, in this case b is a negative 3, so I'm going to put a little negative 3 in there. B squared will be a negative 3 squared times 4ac, 4ac, so a is 2, c is negative 5, all over 2a, so 2 times 2. There we go. And then I got to clean this up and finish solving. So x equals a negative negative 3. A double negative turns it into a positive 3 plus a big square root. I always kind of go slow and clean up my square root. So negative 3 squared means negative 3 times negative 3. So that's a positive 9. And then minus 4 times 2 times negative 5. Look at this. There's a minus and a minus. There's a 2 negatives here. That's going to turn into a plus sign. those two negatives. And then 4 times 2 is 8. 8 times 5 is 40. Okay, so we have 40 over 2 times 2 is 4. Getting there, we're getting closer. We still have more work to do. So x equals 3 plus the square root of 9 and 40 make 49 all over 4. And then I'm really close because the square root of 49, I know in my head. I actually don't need a calculator for this one. The square root of 49 is 7. 7 times 7 equals 49. So I get 3 plus 7 over 4. And be really careful. I see a lot of students do this. They still put the square root symbol over the 7 accidentally, the little radical symbol. But that radical is gone. I did the operation. I took the square root of 49. I got a 7, so no more radical sign. And 3 plus 7 is 10, so I now have an answer of 10 fourths. 10 fourths, which really is reduced down to 5 halves. So my answer is x is equal to 5 halves, or as a decimal, 2.5. On this side, it's going to be all the same math. If I wanted to, I could like repeat my work, repeat my work, repeat my work, but really, it all comes down to the only thing that changes is that minus sign instead of a plus sign. So down at the bottom, instead of having 3 plus 7, I'm going to do 3 minus 7 over 4. That's really the only change. And 3 minus 7 is a negative 4 over 4. And negative 4 divided by 4 is, negative 1. Awesome. So there are my two answers, 5 halves and negative 1. And what those really actually help me solve for is it really tells me that all the way back up here, when I was solving for x and trying to get an answer, that there ends up being two answers. X is equal to, 5 halves, and x is equal to negative 1. I'll circle both of those. Now, if I went and decided to take this a step farther, the next step would be to graph this equation. And we know from what we've been learning in class that when you graph an equation like this, that the graph ends up being one of those parabola-shaped graphs. And what we've basically just figured out is negative 1, which is right here, and at 5 halves, so 2.5, here's 2, here's 3, here's 2.5. At negative 1 and 2.5 on my graph, I'm going to have this parabola passing through. It's going to look something like that. Now, that's not an exact graph. I need to do a little bit more work to find where does it dip down to, how far down does the parabola go, where's the y-intercept. There's more work to be done here, but the idea is we can find these two locations, which we call a root or an x-intercept. Lots of names for the same thing. Okay, so I hope that helps. The big idea really of this video was at the very start when you're given a problem, be sure to rearrange it in order so that the ABCs go in the right order and it's always equal to 0. Okay, thanks guys. Bye.